Okay, today we're going to continue Chapter 4, Lesson 3, and we are going to derive the unit circle. Now, before we jump into the unit circle, I asked you to complete a worksheet, the introduction to the unit circle. And problem number 1 was to find the missing sides for each special triangle. And notice in both triangles, the 45, 45, 90 and the 30, 60, 90, our hypotenuse was 1. Now for a 45, 45, 90 degree triangle, we can label the sides X. Oh, let me try a new pen. X, X to X radical 2. Okay, our hypotenuse is 1, so I'm going to set X radical 2 equal to 1 and solve for X. I can divide both sides by radical 2, so X is equal to 1 divided by radical 2. And I have to rationalize because I cannot keep a radical within the denominator. So I'm going to multiply numerator and denominator by radical 2. So X is equal to radical 2 over 2. So both legs of my 45, 45, 90 degree triangle is radical 2 over 2. Now, my second triangle is a 30, 60, 90 degree triangle. Okay, the short leg is across from the 30 degree angle. This is X. The long leg is across from the 60 degree angle. This is X radical 3. And my hypotenuse is 2X. Okay. Now, in this particular triangle, I'm given the hypotenuse. So I'm going to set 2X equal to 1. When I divide both sides by 2, X is equal to 1/2. So the short leg is 1/2. Now for my long leg, I'm going to take 1/2 and multiply it by radical 3. Okay, and when I simplify this by multiplying straight across, I can put radical 3 over 1. I get the square root of 3 over 2. And so I have a short leg of 1/2, a long leg of radical 3 over 2, and my hypotenuse is 1. Now I'm going to set this aside for just a moment, and we're going to come back to it here in a few minutes. Okay, a unit circle is a circle with radius 1, whose origin whose center is placed at the origin on a coordinate plane. Now, we're going to first look at my 6 trigonometric functions: sine, cosine, tangent, cosecant, secant, and cotangent. Now, earlier in the lesson, we defined sine to be y over r, okay, cosine to be x over r, and tangent to be y over x, once we place our triangle on the unit or on the coordinate plane. Cosecant and secant and cotangent are the reciprocal functions. So cosecant is r over y, secant is r over x, and cotangent is x over y. Now, once we place these triangles on the unit circle, r, which is the hypotenuse, which is also going to be the radius, is always going to be 1. Okay, so when I replace all of the variables r with 1, it's going to change the way that it looks. So sine t would be y divided by 1, or just y. Okay, cosine would be x divided by 1, or just x. Okay, and then tangent would remain y over x. So cosecant would be 1 over y. Okay, secant would be 1 over x. And again, cotangent would remain the same. Now, think about what this does. Okay, a typical point on the coordinate plane is the coordinates x comma y. So we go right x units, up y units, and we have our coordinate point. Well, notice that cosine is x and sine is y. So on the unit circle, when we think about our coordinate points, x, y, we also have to keep in mind that that represents cosine of our angle, sine of our angle. Okay. Now let's move down and let's begin deriving the unit circle. So again, a unit circle is a circle that's placed on the coordinate plane, whose center is at the origin, and whose radius is 1. Okay, so here's the center of the circle. That's at the origin, and the radius is 1, which is the distance from the center to the outside of the circle. So this point right here is the point 1, 0. Now, when we think of this in terms of angles, this angle is 0 degrees, which is 0 radians. Now, if we go straight up the y-axis, we know we have a 90-degree angle, and 90 degrees we found to be pi over 2. These are the quadrant angles. Now, the ordered pair to get from there is I go up 1 radii, or up 1 unit. This ordered pair is 0, 1. Okay. From the origin, if I move left, this angle in standard position is 180 degrees. 180 degrees is pi radians. Again, this ordered pair, from the origin, I go left 1 unit. So the ordered pair is -1, 0. Okay, now from the origin, if I go down 1 unit on the y-axis, this is 0, -1. Okay, this angle in standard position is 270 degrees, which is 3 pi over 2 radians. Okay, these are the quadrant angles. Okay, next, I want to look at the 30-degree angle. Okay, so this angle right here is 30 degrees. Okay, now from on your sheet where we did the introduction to the unit circle, 30 degrees is pi over 6. Okay. Now, what I'm going to do is I'm going to now drop a vertical line from that point, okay, and it creates a right triangle with my angle theta. But remember, I know theta is 30 degrees. So what I have is a special right triangle, a 30, 60, 90-degree triangle whose radius is 1. Okay, because again, this is the unit circle, so my radius is 1. Now, from our sheet, when we had a radius of 1, we know that the short leg is 1/2, and that the long leg is radical 3 over 2. So if I want to get to this point, I go right radical 3 over 2 and up 1/2. So at 30 degrees, my ordered pair is radical 3 over 2, 1/2. Now, there is a 30-degree angle in each of the 4 quadrants. This is quadrant 1. Now, in quadrant 2, my 30-degree reference angle goes from the x-axis to this first line. Okay, and now if I drop this down, it creates a right triangle, and I have a 30, 60, 90-degree triangle. Now, if this angle right here is 30 degrees, then I'm looking for the angle in standard position in which this is the terminal side. I would take 180 minus 30, and this would be a 150-degree angle in standard position. 150-degree angle in standard position is 5 pi over 6 radians. Again, this is my 30-degree angle, so that means my short leg is 1/2, and my long leg is radical 3 over 2. But notice my long leg, I have to move left radical 3 over 2, so that makes it negative, and up 1/2. So my ordered pair at 150 degrees is negative radical 3 over 2, 1/2. So notice for my 30-degree triangles in each quadrant, it's going to be the same ordered pair, but what changes is whether or not the signs are positive or negative. Okay. Now, in quadrant 3, I can also draw my 30-degree reference angle. So 180 degrees plus 30 would make this a 210-degree angle. Okay, and when we converted this to radians, it was 7 pi over 6. And again, 30, 60, 90-degree triangle, okay, my y value is going to be my short leg of 1/2, and it's going to be negative because I'm moving down. And then I have negative radical 3 over 2 for my long leg, and my hypotenuse is 1. Okay. So for my 30, 60, 90-degree triangle with a 30-degree reference angle in quadrant 3, I go left, negative radical 3 over 2, and down 1/2, which makes it negative 1/2. Okay. Now finally, in quadrant number 4, I also have this 30-degree reference angle. I'll draw in my right triangle. So if this is 360 degrees, okay, remember 1 revolution is 360 degrees or 2 pi. 360 degrees minus 30 degrees is 330 degrees, which is 11 pi over 6 radians. Okay. Again, my short leg is 1/2, and because it's down, it's going to be negative 1/2. And then my long leg is radical 3 over 2. So to get to this point, I go right radical 3 over 2, down 1/2. So my ordered pair is radical 3 over 2, negative 1/2. So notice for all 30-degree angles in each of the quadrants, my ordered pairs are radical 3 over 2, 1/2. The only difference is the sign depending on which quadrant we are located in. Okay. Now, I'm going to take a minute and I'm going to erase some of these values, the triangles, just so it is nice and neat and easy to read. Okay. And next, I'm going to look at our 45-degree angle. Okay, so there's our 30-degree angles. Now, from the initial side to this middle line, I have a 45-degree angle. Okay, and a 45-degree angle is pi over 4 radians. Now, we can draw a right triangle by dropping a vertical line down to the x-axis. And I have a 45, 45, 90-degree triangle with a radius of 1, which means my hypotenuse is 1. Now again, we calculated this. When my hypotenuse was 1, each of my legs was radical 2 over 2. Okay, so in quadrant 1, I go right radical 2 over 2, up radical 2 over 2. Those are both positive. Okay, in quadrant 2, again, I have my 45-degree angle. So I'm going to take 180 minus 45, and that's 135 degrees, which is 3 pi over 4. Okay, go ahead and drop down your vertical side and make your right angle, and I would go left radical 2 over 2, up radical 2 over 2. So that's going to be negative radical 2 over 2, positive radical 2 over 2. Okay. In quadrant 3, I have my 45-degree angle. So if I go 180 degrees plus 45, that's 225 degrees, or 5 pi over 4 radians. Okay. If I drop a vertical line to my x-axis, I have my 2 legs, I go left and down. So it'd be left radical 2 over 2, down radical 2 over 2, which is negative radical 2 over 2, negative radical 2 over 2. And in my 4th quadrant, here's my 45-degree angle. So if I take 360 minus 45, I get 315 degrees, which is 7 pi over 4. Okay, here's the vertical line, creating my 2 legs. So I would go right radical 2 over 2, down radical 2 over 2. So that would be a positive radical 2 over 2, negative radical 2 over 2. Okay, so now I have my 45-degree angles in each of the 4 quadrants. Okay, the last angle we're going to look at is our 60-degree angle. Again, I'm going to erase this just so everything is easy to see. Okay, my 60-degree angle goes from the initial side 60 degrees counterclockwise. Okay, 60 degrees is pi over 3 radians. Now, if I drop down my vertical line to create my right triangle, this is my 60-degree angle right here. So my short leg is going to be 1/2, and my long leg is radical 3 over 2. So if I go right 1/2 and up radical 3 over 2, my ordered pair is positive 1/2, positive radical 3 over 2. Now in quadrant 2, I also have a 60-degree angle. Now this is my reference angle. So to find the angle in standard position, I take 180 minus 60, which is 120 degrees, which is 2 pi over 3 radians. Again, if we drop down our vertical line to create our 3rd side, the vertical line represents my long leg, which is radical 3 over 2. The horizontal side is my short leg, which is negative 1/2. So I go left 1/2, up radical 3 over 2. So I have negative 1/2, positive radical 3 over 2. So notice in quadrant 2, the x values are always negative, the y values are always positive. Okay, in quadrant 3, okay, an angle, a 60-degree reference angle, in standard position would be 180 plus 60, which is 240 degrees. Okay, and 240 degrees is 4 pi over 3 radians. Okay. Now again, my ordered pair is going to include 1/2 and radical 3 over 2, but I'm going to be going left 1/2 and down radical 3 over 2, so it's going to be negative 1/2, negative radical 3 over 2. So notice in quadrant 3, both the x and the y value is negative. Okay, finally we have quadrant 4. Okay, from the x-axis I have my 60-degree reference angle. Now to find that angle in standard position, I take 360 minus 60, which is 300 degrees, or 5 pi over 3 radians. Again, you can drop down your vertical line, and I have my short leg and my long leg. My short leg is 1/2. My long leg is going to be negative radical 3 over 2 because it's moving down from the x-axis. Okay, so my ordered pair would be right 1/2, down radical 3 over 2. So in quadrant number 4, the x value will always be positive and the y value will be negative. Okay, this is the unit circle, and the unit circle can be derived from our 30, 60, 90 degree special triangles, and our 45, 45, 90 degree special triangles. Okay, and we're going to use the unit circle to solve and evaluate trigonometric functions of special angles.